In this video, we're going to evaluate the 6 trigonometric functions, and we're going to use the 2 common angles. We're going to use our 30, 60, 90, and our 45, 45. And so let me grab this really quickly. I have this, I've misplaced it. Give me 1 second. Right here. This is an example of our 30, 60, 90, and our 45, 45. So if you recall, we need to first understand where is 135. So if this is my start line, notice that 135 is right here. This is 135. 135 is way over here, right? And so if you think of those triangles, when I first showed you pink triangles and green, this is an example of a green triangle. This reference angle is 45, so greens are 45. But here's the deal. I don't want to go to positive 135. I need to go to negative 135. So how do I get there? I start here. Here would be 1 triangle, 2 triangle, 3 triangles. So here is where negative 135 lands, negative 135. Now we need to create, with our reference angle, we need to create a triangle. We always go back to the x-axis. So as you go back to the x-axis, you're going to make a 90-degree angle. And then I would like you to color in the part of the triangle that's closest to the origin. That's always going to be the angle that we are going to evaluate. So I'm going to draw that picture. This is the angle that we're going to evaluate. And so we need to know all the angles of the triangle. I know this is 90, and so these two also have to add up to 90. Well, what angle is that? Well, I know that half of a circle is 180, and I've already done 135 backwards. So if I take my calculator and I take 180 minus 135, I end up with 45. That means this remaining part is 45. So this is 45. Well, these two have to add up to 90. So 90 minus 45 is also 45. Now, looking at the notes we took previously today or yesterday, I'm going to go back to this picture. Across from each 45, I'm going to place a leg that has a distance of 1, and across from 90 degrees is going to be a distance of square root of 2. Okay, now let's write this down. We have the sine. These are our primary trig functions, sine, cosine, and tangent. And then the secondary ones will be cosecant, secant, and cotangent. After I've created the triangle, first locate the line, create the triangle always going back to the x-axis, identify what angle, it's always the angle closest to the origin. Now it's time to determine the signs of these 6 trig functions. These are primary, these are secondary. These two are related. How are they related? They're inverses of one another. They'll always have the same sign. These two are related. They'll always have the same sign. They're inverses. These two are related. They'll always have the same sign and they're inverses. Let's get started. In quadrant number 3, all-star trig class. That's an acronym. What does it tell me? All things are positive. Only the sine is positive. Only the tangent is positive. Only the cosine is positive. This terminal angle landed in quadrant number 3. That acronym tells me that only tangent is positive. So right away, tangent and its reciprocal is positive. Everything else has 1 negative in front of it. It's time to get started. So notice this triangle has 3 different sides to it. All we're going to do is we're going to follow directions. It's like following a manual. Okay, sign, ready? We're going to make a division sign. Got it. And the top number is going to be opposite of the angle that I am going to evaluate. The bottom is going to be the hypotenuse of the triangle. Okay, opposite of this is 1. The hypotenuse, which is opposite of 90, is the square root of 2. We'll come back to that later. Cosine. We're just going to follow the directions. Cosine, the manual says the top number is adjacent, the bottom number is hypotenuse. Got it. So from this angle, top number is adjacent, which is 1, and the bottom number is hypotenuse, which is across from 90. Tangent is opposite over adjacent. Okay, from this angle, opposite over adjacent, 1 over 1. All of those mathematically are correct, but it doesn't mean they're proper. Remember, proper means you can't leave with a square root in the denominator. We're going to come back to that later. First, we're going to know, and we're going to do half the work. Remember, these two are related. How are they related? They have the exact same sign, and then we just take the reciprocal. So we flip them. So the square root of 2 goes on top, and 1 goes on the bottom. Square root of 2 goes on top, 1 goes on the bottom. 1 over 1. Mathematically, I feel extremely confident these are right. Now we need to make sure that before I circle a final answer, that it's in proper form. Mathematically correct, not in proper form, and at the Algebra 3-4 level, it needs to be in proper form. Where is the mistake here? You can't leave a final answer with the square root on the bottom. So here's a shortcut. You keep the number on top the same, so -1. You take the bottom and throw it up top, and then rewrite the bottom with no square root. Same thing here. Can't leave a square root. Leave the top the same, throw the bottom up to the top, and rewrite the bottom with no square root. This doesn't have a square root on the bottom. This doesn't have a square root on the bottom. This doesn't have a square root on the bottom. This doesn't have a square root on the bottom.